Hello, my name is Michael Driscoll, and in this tutorial we will be learning about sets. A set data type is defined as an unordered collection of distinct hashable objects. According to the Python 3 documentation, you can use a set for membership testing, removing duplicates from a sequence, and computing mathematical operations like intersection, union, difference, and symmetric difference. There are two types of set built into the Python language. Set, which is mutable, and frozen set, which is immutable and hashable. We will focus on set itself. Creating a set is pretty straightforward. You can create them by adding a series of comma-separated objects inside of curly braces, or you could pass a sequence to the set built-in function. Let's look at an example. So here we have a set. My set equals curly brace and then a series of strings. This looks kind of like a dictionary, but in dictionary you have key value pairs where the keys and the values are separated by colons. So if you want to change this into a dictionary, you could do this, and then it would become a dictionary because you'd have key value pairs. But this is a set. So let's go ahead and undo that. When you run it, you get ABC. If you ask what type it is, you can see that it is the set type. Let's go ahead and try to create a set using the set function. So here we have a list, 1, 2, 3, 4. It's integers, and you can tell that it's a list because of the square brackets. To convert this list into a set, you can just call set on that particular list. When you run this, you can see that it now has curly braces around it. One nice thing about sets is that they will get rid of duplicates. So if we rerun this code with these duplicate 4s in it, you can see that the sets have changed. The set gets rid of all the extra 4s. So if you put a 3 in there, you'll still get that. If we add a 5, now we have a 5 in the output. So that's kind of how that works. If you want to access a member within the set, you can use Python's is operator. So we could say A in my set, and it should return true, which it does here. Let's change this and try C. And that's in there. Let's try D. False. D is not in this set. Sets do not allow you to use slicing or the like to access individual members of the set. Instead, you would need to iterate over a set. You can do that using a loop like the while or for loop, but I'm not really covering those in depth until a later tutorial. This particular tutorial is based on my book Python 101 second edition, but I'll go ahead and show you an example of using for loop here. So let's start out by printing out the set. Print my set. So my set looks like this. For item in my set, it goes through and prints out each individual item, B, A, and C. Once a set is created, you cannot change any of its items. That is because a set is immutable. However, you can add new items to a set. So let's go ahead and find out how. There are two ways to add items to a set. You can use the add method or the update method. We'll try the add method first. So here we have a set, A, B, C, C. If we print it out, let's go ahead and do that quick. Let's print out my set. If we do that, you can see that it automatically gets rid of one of the duplicates for you. Then we add D, which it then adds D to the set by using the add method here. If you'd like to add multiple items all at once, then you should use the update method instead. So here we have the same set, A, B, C, C, and we want to add a D, E, and F. So this is a list, D, E, and F, that we pass as an iterable to update. So when you run this, it'll add all the new items. Let's add another one quick. You'll note that when you add them, they kind of appear in whatever order they want to, because sets don't really care that much about order. Note that when you're using update, it takes any iterable that you pass to it. So we could take a list, tuple, or even another set. If you want to remove items from a set, there are actually 3 different ways to do that. You can use the remove, discard, or pop method. Let's try using the remove method. Remove will remove whatever you specify. So in this case, it will look for A and remove it. So we run this, it removes A. Let's get rid of B. If we remove it, you can see that B is no longer in the set. If you run this with C, it will get rid of C. If you happen to ask a set to remove an item that does not exist, you will get an error. So I've already run this code once. Let's try doing it with D. So D doesn't work. You can see that it gives you a key error. D does not exist. Remove A, it works. You don't get any errors. So this only throws an error if you try to remove something that is not already in the set. The discard method works almost exactly the same way as remove, in that it still removes a specified item from the set. So this will still work. We should probably print my set at the end. So you run this, it gets rid of B, so you're left with A and C. But the difference with discard versus remove is that discard will not throw an error if you try to remove an item that doesn't exist. So in this case, if I run this code, I get no error. It just kind of eats the error for you. So if you're used to catching errors and displaying a message to the user, you'll probably want to use remove instead of discard. Okay, the pop method will remove and return an arbitrary item from the set. What that means is that when we run this, it could remove any item from the set. So here I'm running it multiple times. Sometimes it removes A, sometimes it removes B. You don't really know what pop will remove. It's kind of random that way. Let's add a couple more to this and see what happens. H. Then we can run it. Will it always be B? Yeah, in this case, it's always showing up as B, but it depends on each time that you run it. Sometimes you'll get something different. If your set is empty and you try to pop an item out of it, you'll receive an error. So let's go back. Let's see, let's change this to only have 3 items in it. And then we will call pop 4 times. So if you run it too many times, it'll pop out the items 1, 2, 3, and then the 4th pop, you get a key error, pop from an empty set, which doesn't work. Okay, so what if you have a set that's large, or you just, for some reason, you want to clear or delete it? To empty the set, you can use the clear method. So if I run this and I run clear, you just end up with a set object at the end. It's just an empty set with nothing in it. If you want to completely remove the set, like get it completely out of Python's memory, you can use del, which is a Python keyword. So if I run this, it will delete this variable in the entire set. And then if I try to access it, you'll get a name error. So, normally you wouldn't try to access it, you just delete it. But I'm trying to show as a demonstration that if you did try to access it, you can see, obviously, that it doesn't exist anymore. So there are some different set operations. You can use union, which combines 2 sets and returns a new set. You can use intersection, which returns a new set with the elements that are common between the 2 sets. And you can use difference, which returns a new set with elements in the set that are not in the other set. These operations are the most common ones that you'll see when you work with sets, but the set data type supports several other operations that I'm not going to cover here. The union method is kind of like the update method that you learned about earlier, in that it combines 2 or more sets together into a new set. However, the difference is that it returns a new set rather than updating the original set with new items. So if I run this, first set equals 1, 2, 3, second set equals orange, banana, peach. First set.union of the second set will add the 2 together until you get 1, but it's returning a new set. So if I try to access the first set again, you can see that it's still 1, 2, 3. So this is just this line 3 is just returning a new set. It's not actually setting first set to be a combination of first and second. In this example, we created 2 sets and then used union on the first to add the second set to it. But union doesn't update the set, it creates a new one. So if you want to save the new set, you would create a new variable name, like united set, and then you'll get to keep both of them together. The intersection method takes 2 sets and also returns a new set. But in this case, it only contains the items that are the same in the 2 sets. So let's look at an example here. So first set, second set, the intersection between the two is 1. 1 is the only item in both sets. So when you run this code, you will end up with only a set of 1 item in it. Let's update this and add a banana to the first set. Now when you run it, the intersection will be 1 and banana because they are both in both sets. The difference method will return a new set with the elements in the set that are not in the other sets. I find this a little bit confusing to think about, so usually I just go ahead and create an example. So here, we take the first set and we look for differences. So the first set has 1, 2, 3. The second set has 3, 4, and 1. So the difference between first set and the second set is that the second set does not have 2 in it. So you get a 2 as the return value. Now we could add 5 here, run it again, and you get 5 and 2 because neither of these are in the second set. When you call difference on the first set, it returns a set with 2 as its only element, because it is the only item not found in the second set. So you can kind of play around with that and see how that works. And that's basically the end of my presentation on sets. If you have any questions, feel free to drop them in the comments. Otherwise, I'll see you next time.